All right, our lesson is involving exponentials. So we're going to solve exponential equations with like bases today. So just as a warm-up type of problem, I want you to look at 5 times 2x minus 2 equals 5 times x plus 5. How would you normally solve this? Well, if you're like me, you cross out the 5's because you divide by 5. And so then you would say 2x minus 2 equals x plus 5 and go from there. So you'd subtract x and you'd add 2 to both sides and you end up with x equals 7. So when we're solving exponential equations, it's very similar to that same thing. So if you have an equation and the bases are the same, then what must be true about the exponents for the equation to remain equal? Obviously, they are the same. So this is an exponential equation. 2 raised to the x plus 1 equals 2 raised to the 3x minus 5. They both have the same base, so then the power, or the exponent, has to be equal. So you would say they are the same. And then if we solve this, we would just say, oh, x plus 1 equals 3x minus 5. We add 5, we have 6, and we subtract x. 2x equals 6, and we would get x equals 3. Now, what if the bases are not the same? Well then, we need to make them the same using exponents, changing the larger base to a smaller base raised to an exponent. So let's take a look at a few examples. So these first 3, we just want to rewrite the equations to where both sides have the same bases. We're not even solving, we're just setting it so they both have the same base. So we have 2 to the x and 64. So obviously 2 to the x is not going to change because we don't have a smaller base than 2. Now 2 to what power is 64? And so if we think about it, 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16, 2 to the 5th is 32, and 2 to the 6th is 64. 36 and 6 a little bit easier. We know 6 to the x, and we know this is 6 squared. 36 is 6 squared. How about 3 to the x and 81? 3 squared is 9, 3 to the 3rd is 27, 3 to the 4th is 81. 3 times 3 times 3 times 3, 81. Okay, now let's try to do the same thing, but we're going to solve. Sounds difficult? Not really. Doesn't really sound that difficult. So this is going to be 5 to the 2x plus 3. We're going to leave it. 5 to what power is 125? Well, if you think about it, 5 squared is 25. 25 times 5 is 125. So 5 to the 3rd. So once we see that, we get rid of the bases and then set the powers equal to each other. 2x plus 3 equals 3. So when we subtract 3 from both sides, we get 2x equal to 0, or finally x equals 0. For our next one, 3 to the 2x minus 1 equals 27. So we know we're going to leave this as 3 to the 2x minus 1. And we already kind of said before, 3 to the 3rd power is 27. We can cross out the 3's now and set the exponents equal to each other. 2x minus 1 equals 3. So it's really kind of nice when you're dealing with exponential functions, because once you get the same base, then you're just setting the exponents equal to each other, and usually the math works out pretty nicely. So here 2x equals 4, x equals 2. So once we have the bases the same, you can see like the algebra we're doing is not very difficult. 2x minus 1 equals 3. We all kind of learned that probably in pre-algebra class. And last one, 3 to the 2k equals 3 to the negative k. Well, get rid of the 3's. They both have the same base, so now set the exponents equal to each other. 2k equals negative k. I always get people on this one. This just means add k to both sides. 3k equals 0. K equals 0. So there you go. Solving exponential equations with like bases, that's some of the easiest math we will do all year. Now stay tuned for solving exponential equations without like bases.